families that are the ones that we can open up and edit, the ones that we can create a library of, the ones that we can download off the internet, and so forth. To look inside a Revit family, we just click on the Edit button, and that takes us into the family editor. A little bit, I guess, like the block editor, perhaps in AutoCAD, some similarities. It's a very simplified type of environment. It's only got commands in there that are obviously relevant to the actual task at hand. Okay, so what we've got, let me just move this dock here so I can see what I'm doing. Okay, so inside the actual family editor, it's pretty much like you would expect to see inside the project. We've got a project browser here, and we've got the properties window. But we also have visibility graphics settings, as we do inside any project. As you can see, when I reveal the walls category, this object appears. Now that is actually what's referred to as a generic host. So in a Revit family, in this particular case, it's a door. Doors are wall hosted. There's a generic host that's placed here, or that appears inside the family, and then I place my geometry and so forth to represent the door. And when I place this into my project, Revit swaps out the generic wall and places the component family into the actual wall that's in the project. So we'll come back and have a look at this in more detail, because this is sort of the end part of the exercise. But you'll also notice that when I click on these objects here, they're not actually geometry. They're actually what's called symbolic line. So inside your Revit families, even though I guess we automatically think of geometry, there is in most families you'll find that there's actually quite a high reliance on these symbolic lines and other objects. And they're a very lightweight and quick way of actually getting the object, the family, to look correct in the project the way that we expect to see it, and without having to resort to all sorts of creating geometry and so forth. Let's close that up. Now inside this project, I've also got, under Casework, I've got this overhead cupboard. I'll place that in there. Slightly different behavior. You can see that Revit has placed that Casework on the wall, and that's effectively hosting that Casework on the wall. Now the difference is this door is hosted in the wall, and then this piece of Casework is hosted on the wall. And I'll just explain a little bit about why I'm making that distinction. If I want to create a new family from scratch, I just go to the big R, I go New, and I go Family. First thing that I have to do is, I guess, make a decision here about what category of object I want to create. So for example, in the case of the overhead cupboards that I created just before, the correct template would be Casework wall-based. And you can see there in that little thumbnail, hopefully, it's clear enough to make out that there's a generic host in there. And the expectation would be that when I go to create that, it looks for a wall in the project, and it forces me to place it on a wall. If I was to use Casework, then Revit wouldn't have that requirement. It would just allow me to place this Casework anywhere in the project in a plan view that I wanted to. You can see that basically all the different categories of objects are represented here in the templates. So you've got all your sort of structural elements. If you're running Revit LT, you're not going to see these because these aren't sort of available in LT. Or certainly not in the actual default library that gets installed in Revit LT. That's not to say that you couldn't get hold of these templates anyway. Under lighting, you'll notice that there's actually quite a range of different types of lights. You'll see, for example, that there's a ceiling-based light. Now, the idea there is that when you place this into a project, Revit will expect you to place the object in a view where you can see a ceiling. It won't allow you to place this light fitting anywhere where there isn't a ceiling, so you'll have to be in a ceiling plan, or perhaps in an axonometric view where you can see the ceiling. And that would be something like a ceiling-based fluorescent light fitting. Then you've got this wall-based one, and in the same fashion as the casework here, that's going to be looking for a wall to host itself on, so that would be like a sconce or an uplight. Then you've got your generic lighting fixture that would be something like a floor-standing pedestal, for example. Okay, and also just one thing too, probably not all that obvious from the preview, but you can see a little yellow object in the middle. That's actually a real light source. So when I place this light fitting in there, there's actually a light source in the family, and if I hit the render button, then that's what actually generates light from that family if I do a photorealistic render. In recent additions to the cloud rendering services, there's also the ability to do lighting studies, and that's going to be using information in this light source that tells Revit how many lumens the object is actually emitting and what shape the light's emitting in. You'll also note, though, that we've got these generic models. So picture these as sort of a very basic starting point to allow you to create some different types of families. For example, I've got the ability here to create a line-based family. So if I wanted to create a family that was, say, an awning that I could very quickly place around the front facade of a building, I can create a line-based family, and I can be in a plan view or an axonometric view, and then click and place this repeated series of, say, roof sections and brackets in the same way that I could click and place a run of walls. So that's a very powerful tool as well. We're actually going to start off here just by using the generic model. So picture this as just your sort of blank starting point. And if I open that up, we're now in the family editor with just this blank template ready to go. Now, what we'll do is actually, before we even kick off, we'll just go here into this family category and parameters dialog, which is this top left-hand one. And before we do anything, we'll actually just put this into the furniture category. So what you can actually see here is that Revit allows me to switch between categories. That's something useful to remember. So you can actually repurpose a door and tell Revit that it's a window if you need to. There are some limitations there. So there's certain categories of objects you can't switch between and so forth, but that's just something to be aware of as a bit of a trick. By changing it to that category, it will subtly affect the way that Revit treats it in the actual project. So for example, if I were to make something a piece of casework and I was to cut through it in the plan view with the view range, so the primary cut plane sliced through that object, Revit will actually show all the geometry inside the object. It will actually slice through it as if I was, physically cutting through it at a certain height. If that exact same family was placed in the project and was classified as a furniture item, no matter where the cut plane is in the project, Revit will always show it to me as if I'm from above. And that sort of makes sense, because if I'm cutting through a piece of casework in a 1:20 drawing, I would normally expect in a set of working drawings to see the internal cabinetry, the shelving and so forth, and that's sort of based around the way that we expect to see objects in the actual working drawings. In the case of a piece of furniture, we don't expect to see a piece of say, a chair, for example, being sliced through. We expect to see furniture always represented as if we're looking at it completely from above, and so Revit respects that. Okay, so we'll make it furniture anyway, and we'll click OK. All right, so when we're creating families, I think this is probably the thing that maybe trips people up most commonly, especially people who might have come from a 3D CAD background. The very understandable temptation is to just start creating geometry. But in Revit, we sort of have to work a little bit back to front. And what we do, first of all, is create reference planes. So to give you an idea, I'll draw an analogy. It's actually a pretty good analogy. I didn't make it up myself, as much as I'd love to claim responsibility for it. But reference planes are a bit like a skeleton. So in your body, you've got your skeleton, which is your framework, your structure that holds everything up. Then you have muscles. We haven't created the muscles yet, but we will in a sec. The muscles are what will drive around the skeleton and make it parametric. So in the case of a family, if we need it to be rescalable inside the project, like a door or a window or so forth, then we need to make it parametric, rescalable. And we'll do that in a sec. And the last piece is the flesh, and that's the geometry. So the geometry actually hangs off the skeleton and then gets driven by these muscles, by these special dimensions that we'll create in a sec. And that's, I guess, why people can tend to get a little bit sort of tripped up, because they automatically create the geometry. If you haven't created this framework first and correctly made it parametric, then you're, again, with this analogy, it would be a bit like having muscles and flesh, but no skeleton. You're going to be a lump of flesh on the floor. You're not going to be able to move anywhere. So anyway, we'll create these reference planes. Actually, I'll just very quickly go back and do that because I was talking while I did that, and I'll go back over that again. So reference plane, I'll create one to the left. Placement is not important at this point. Now, the proper way to do this as you're going through is to actually pick from this list here of what it actually represents on the actual object. And I will do that because I'll show you in a minute why that's actually a useful thing to do. If you are creating content for a third party, like you've been actually asked to generate content, these are all the sort of ways that you're supposed to do things in Revit. So I guess if you're doing this and you expect to sort of give it to a third party and maybe even charge to do this, then of course doing it correctly is obviously something that's paramount. There are standards that have been created in Australia that cover the correct way to create Revit families, and they're generally regarded by people as being a sort of a useful standard. So you've got back and I've got front. I'm in plan view, so that effectively there is the back of the object, just to give you an idea. So I'll now go to a front view. I'm in an elevation view. You can see these reference planes that I created before. So those go infinitely through the project. These are vertical reference planes that infinitely go about, below and above and backwards and forwards and so forth. What I've also got here is this reference level. Now that's a little bit different. I'll just drag that over away like so. What I've got at the bottom is a reference plane, just like I had here, and then I've got this reference level object. When we are placing dimensions, we always dimension to the reference planes. That's that same analogy of the muscles and the skeleton being correctly connected. You don't want to be dimensioning to this reference level. That can be a problem. When you're in the project, you might have noticed when you place furniture items, for example, you have this parameter that you can control the offset from the level, and that's what this little device does. If I place this object later on and then say offset from level 200, it will offset it from the level that I've placed it into. Okay, very quickly, I'm just going to create a reference plane across the top, and again, I'm going to call that top, and I'm going to call it top. There you go. One thing though, by default, when I do use any of these names, Revit will allow me to dimension to this. Sometimes you will create reference planes in a family that you don't want the user to be able to dimension to automatically, just for the sake of convenience, because it's just something that you might have put in there just to constrain something and you don't want to confuse the user. In that case, what you can actually do is you can say not a reference, and then what will happen in the project is the user will then have to purposefully tab over the object to actually select that reference plane. Alrighty, so here we go. We've got our skeleton there all ready to go. We still need to be able to control this parametrically, and that's where we start using these special dimensions. They're called label dimensions. So I'm going to create, first of all, an equality constraint here, and I'll just explain just before I do that. You'll notice that these center reference planes that we started out with, they're automatically labeled. They're also pinned, can't be moved around. But also there's a special parameter here that says defines origin. If I click on that one, you'll see that that says defines origin. Where those two intersect, that's the insertion point of the object when I place it in the project. Also, when I resize the object, it will resize itself around that insertion point, I guess in the same way as an AutoCAD block, for example. If I was manufacturing an L-shaped workstation, it wouldn't make sense for me to have the insertion point in the center of it and for it to rescale around that center point, because if I had a cluster of 4 workstations and I resized them, they're going to end up spreading into each other, which is not desirable. In that case, all I have to do is just go to this reference plane here and say defines origin. Defines origin on that one. You can see these ones have automatically unticked themselves. And now the object will resize itself and insert itself around those two, where those two reference planes overlap. In this case, we want it to be in the center, so I'll just bring it back to where it was. Okay, so again, these dimensions. So because this object's going to be resizing itself around the center, in order to keep, when it's resizing, in order for it to resize equally from that center point, I'm going to use the good old equality constraint. And again, equality constraint. So all these constraints are very, very useful inside Revit in the project, but what you realize is inside the actual family, they're actually the bread and butter of the way that you create families. So they all start to have a sort of an added dimension of relevance. What I'm going to do then is create, noticing of course that I'm dimensioning to the reference planes exclusively. I'm then going to create, I'm going to transform the standard dimension into what's called a labeled dimension. So I'm just going to go up here to the options bar, and because there's no parameters for me to pick from at this point, I'm just going to tell Revit I want to create a new one or add a new one. I'm going to call that width. Very important. I'm going to call that, I'm going to give that a capital W at the start and lowercase from there on, and that's just a standard internationally recognized way of naming objects and naming parameters inside Revit. I'm also going to create it as an instance parameter. Now, hopefully you guys have all sort of got an understanding of the difference there. Just to try and explain that, if I make this width parameter an instance parameter, it will mean that when I place it in the project, the user will be able to give every single one of these objects their own unique value for that parameter, so that every instance will have its own unique width number. If I were to make it a type parameter, then what would happen is that width factor or width parameter would be locked into various family types. So there might be a large cube, a small cube, and for each one of those it will have a preset width value. And that's good. I mean, obviously, if you were a manufacturer that only made certain lengths of desk and you had a parameter in there for length, you're going to make that a type parameter because you don't want people being able to manipulate it, create some sort of customized length, order it, and then suddenly discover that it's not available, it's not in your catalog. So let's make it an instance parameter. Okay, and I'll just keep powering through here. I'm going to make this a cube, and I'm going to add a new parameter, and I'm going to call that depth. Again, instance. You see that Revit's automatically taking care of a few things. Because it's on a dimension, it's actually automatically making it length. So there's my depth. Now, what I could do also as an exercise, rather than placing the dimensions and then doing each one as I go, I can actually go here to the family types dialog and actually add it here. So as you know, you'll find a lot in Revit, there's sort of multiple ways to get to the same place. I'm going to call it height. I'm going to make it instance. It's going to be a length parameter. Now that just happens to be correct. This may not always be correct, so just be aware if you're doing this, don't assume that Revit's going to pick the correct sort of type of parameter that you expect it to. In this case, it has. This is where it gets grouped here in the list of parameters. So that really doesn't affect anything except that if I was to put that under graphics, what will happen is there'll be a new subcategory of parameters here, and that dimension will be placed there. So obviously just have a bit of a think about where you want to place things. Okay, we've got height 0. Let's just give it a value. It's not actually controlling anything at the moment, but what I'm going to do is come in here. Now, I don't need to put the equality constraint in here. Again, this is what I mentioned before. Do be very, very careful not to dimension to the reference level. Just make sure that you're dimensioning to that bottom reference plane. Click on that, and now because we've already created height, we can actually pick that from the list. By the way, you can also reuse dimensions. So if the width and the height were always the same, there'd be no reason why you couldn't actually reuse, you know, that same parameter in different labeled dimensions as well. All right, so we're getting there, but not quite, because if we load this into the project, we're not going to see anything at this point, and that's because we need to create some geometry. This is going to be a very simple object. It's just going to be an extrusion. Now, at the moment, Revit's taking care of placing the active work plane when I go to place the extrusion. Revit does this for you all the time inside the project. It does it for you inside the family editor as well. Sometimes you can actually, you do have to override that. So you can go in here and tell Revit to show you what the active work plane is. If I flick through to the axonometric view, I can't see anything. Of course I can't see anything because there's no geometry. But that's the work plane there at the moment anyway, to give you an idea. I'll just switch that off. Okay, so I'm going to create the extrusion, and I'm just going to create a rectangle like so. Now, I mentioned before about how your constraints in the Revit families are really, really important, and that is very true here, because what I need to do is make sure that the edges of this extrusion are adhered to my reference plane. So again, that analogy, these are the flesh, this is the flesh. It needs to be stuck to the skeleton so that when the skeleton moves, it moves. And of course, that skeleton's being driven around by those parametric dimensions. So one of the tricks you can do here is if I activate the Align tool, I can just click on this edge here, or click on that reference plane rather, click on the edge. I can click the padlock and actually keep going. So I don't need to get out of that Align command. I can click on the padlock whilst I'm in the command and keep going. So that's nicely stuck that to that. What it hasn't done though is stuck the top. So I'm in the front view again. You notice that Revit's picked that arbitrary height of 250 mils. Don't know quite why it picks that as the standard height for an extrusion, but I guess they had to have some number. We'll go to the Align tool, grab that top reference plane, and then we'll use the Align Constrain tool to stick the cube to that top reference plane. So I can drag that around just to give you an idea, but that's probably not the best way to do this. What we really want to do is what's called flexing the family. And that effectively is, make it shaded, there you go. So I'll just pull that over to the side so you can sort of see it there, and then I can simultaneously open up this dialog. We can see it working there. Okay. Very quickly, before when I said that this was an instance parameter, you'll notice that next to that it says default. That's how I know it's an instance parameter when I open up a family. What that says is that whatever value is in here is the value that Revit's going to put the family in at by default. So obviously when you're making a family, you want to just put in a default value that sort of reflects what's a common sense size for the object, or it doesn't necessarily mean size. So remember that these parameters can include things like visibility, material, and so forth. It's not just size that we're talking about. Anyway, so to flex the family, I'm going to test this. Now, in the case of the cube, it's a very simple object. I don't expect this to have any problems. If it was a complex object with multiple pieces of geometry, I would expect that at some point I'm going to create something and then flex it, resize it, and then discover there's a problem. If that were the case, then typically there'll be two things that will happen when I flex the family. One of them is that I'll get an error message popping up saying that Revit's going to unconstrain the object because it can't work out how to resolve the dimension. And the other thing is that the object might just simply not resize itself because the geometry hasn't been correctly constrained. Of course, I'm not having any problems here. I'd be very worried at this point if I did. So anyway, there you go. That's flexing the family. So it's sort of taking it to logical extremes in size. It's making it really small, making it really large, trying to test it to see if it's basically going to break. Alrighty, so we'll save that as a family. I'm just going to call this cube with, there you go, there's one already made for me, look at that. Save that, overwrite, and then load that into the project. And I'm going to place a few of these in the project. When I select them, you will note that I've got the blue groups on them. That's very standard for an object with instance parameters for its dimensions. You can see, of course, that as I manipulate those, there's no relationship between the different objects, and that is again because of the fact that they're instance parameters. You can also see, though, that if I did need a specific value rather than just dragging it around randomly, I can actually key in an actual real value, which Revit will then use. All right, so that's my cube with instance parameters. What I'm going to do now, though, is sort of extend this a little bit and show you how we can actually use this, how we can use type parameters. So to give you an idea, actually, just before I do that, I'll just save this, save as family, and save as type parameters, making sure I don't save over these backup files. It's a mistake that's very easy to make when you're in a rush. Also, when I am saving the family, at this point I can actually define the number of backups that are going to be generated, and just tell it to, by default, always open up in the 3D default view if I want to. Okay, so I'm just going to save that as type, overwrite. Then what I'm going to do is I'm going to start making some family types. First of all, before I do that, though, is I want to change these. I want to convert these from instance parameters into type parameters. So there's two ways I can do that. One way is to just click on the parameter and go modify parameter and go type. Another very quick way to do it, though, is to actually click on the dimension, the label dimension, and change the label dimension by unticking the little box that says instance parameter. That's sort of a newish feature that's been around for a few versions that can save people a bit of time. All right, well, that's the first part of the process. The second part of the process is actually to define the family types. Okay, so I'm a manufacturer. I make cubes. I have two models. One is called the mini cube. One is called the maxi cube. So the first thing I do is I define the family types. And I'm going to say mini cube. And the mini cube, oops, is 1500 by 1500 by 1500. It's not very many, is it? But anyway, we'll go along with this fantasy. Okay, so then this is where I start putting in my data. This is what's going to show up in the scheduling, for example. And I can start to put in all sorts of, hypertext links and so forth, and then maybe a bit of a cost value. So this is like quite a cheap little thing. At the very end of this process, I hit the apply button. I guess you could say that's a bit like you're taking a snapshot of all those values and applying them against that family type. If you don't do that at the end, there's a good chance that these changes won't actually stick. The next thing I need to do is the second cube object that I sell as a manufacturer is called the maxi cube. This is a bit more substantial, so it's 3 meters by 3 meters by 3 meters. I can't imagine where you would actually use this object, but anyway. Again, we'll just go along with the fantasy. All right, so we've gone apply, and you can see now that's taken a snapshot. So if I click on Minikube, you can see that all those parameters update, well, they're not automatically, but they're updating now that I've applied those changes. If they don't change at that point the way you expect, then just retype over them and hit apply. That's sort of your way of checking that. You'll also note that when I do hit the apply button, that in this case the cube is resizing itself. So again, this is flexing the family in a type parameter scenario. Alrighty, so We'll save that and we'll load that up. And it's not going to let me place that in an elevation view, so I'll just go down to furniture. It was furniture, wasn't it? Yes. Okay. Cube with type. Right-click on there and go Create Instance. And right-click on the mini-cube, Create Instance. Again, like any other family with type parameters, like our doors, for example, we can go here to the type parameter. On top of all that, though, there are instance parameters. Even in this family with type parameters, there are still instance parameters that are unique to this one object. So this could have a number 0, 1, for example, and this one might be 0, 2. Of course, I'd use these for scheduling purposes and ordering purposes. There's that offset I mentioned before, and I said to you about how you've got that offset value that you'll see if I just go to the site elevation. I'll just drag that over so we can see it. You notice that that's actually sitting 200 above the reference level. There it is, yep. So that's being driven by that instance parameter. Okay, so that is, just to recap quickly, that's the basics of how you pick a family category, how you place in your reference planes, your labeled parametric dimensions, and then how you constrain the geometry, place the geometry in, and then from there we looked at how you can create instance parameters to allow objects to be sort of customized per object, and then how you can create type parameters, and I guess a bit of discussion about the logic of why you would choose one over the other. Okay. We're going to go back to the family, and we're just going to sort of extend on what we've done here. Okay, just a few things. First of all, this is just a generic default material. It's just put it in as a generic gray material at this point, but of course this is geometry, so I can define material for it. So when I click on there, you can see that that little open dialog button pops up, and that allows me to open up the material browser. Now, you may not have ever played around in here, but just to be aware that when you do install Revit or any of the Autodesk products, there is an Autodesk library of materials that gets installed, and if I click on this little button here, Open Asset Browser, that actually reveals that entire catalog of materials. So what I'm going to do is I'm just going to pick something like, try and spell that correctly. Let's just pick just a generic one. I'll double click on it. You can see over here that default has now been overwritten, and it's now using that material. I'll click OK. Switch to a realistic view, and there's my aggregate there. On top of that, though, if I click back on that geometry, so that's sort of the default material that it'll load with. So you're going to pick something there that's going to be appropriate to this actual object. So that'll be like a starting point. But then what I can also do is give the user control over this inside the project. And the way that I do that is I click on this little associate family parameter. In this case, I don't have any material parameters in the family at this point, but I can very quickly create one. I'm obviously going to give this a name that sort of makes sense. So it's the cube body, and it's cube body material. Now, because I want the user to be able to customize this in every object, I'm going to make it an instance parameter. And click OK. Now, I'll just load that back into the project, and I don't think I actually did that correctly. Let's just try that again. Let's see if it applied it. Yeah, okay, that was a bit of a mistake. I'll tell you what I did wrong. I'll just explain. I'll just make it cube material, make it instance. When I went to load in that family, Revit then asked me if I wanted to override the object. But then there's a second option, which is to override the parameter values. I picked this one by mistake, so it didn't take that new parameter that I created with the material and add that to the version of the family inside the project. So that was a mistake, but by doing that, fingers crossed. Did it do it? Oh yeah, I know what I've done wrong. Okay. And I'll tell you another thing I did wrong too. Hang on, let's just go back. So that material, yeah, that's an instance parameter. Okay, maxi cube, load into project. Maxi cube, and can't quite. There it is. Brain's switching off on me at the moment. Okay, so that's the reason why it's coming up as that sort of generic. It's sort of, that's the default in the project that all objects that are in the furniture category are going to come up as. So what it requires me now to do is to click on that little, open the material browser dialog, and then pick, where is it? Cherry, there you are. Pick a material, and there it is. So that's how you can actually create a material parameter in a family. Okay, so moving on. A few other things that are essential to do inside families. If you look inside, I'll go back to this project. I know I'm skipping backwards and forwards here, my apologies. If I click on this, or look at this family here, before when I opened up this door, remember I pointed out that this door swing and this door leaf aren't geometry. They're just a symbolic line. Another thing, though, is that they are actually, inside the family, assigned a subcategory. So what does that mean? Well, you'll notice that on each view you have the visibility graphics override settings, and if I go to doors here, for example, I can hide all the doors. But what you've also got on top of all that are these subcategories. Now this is where you get this fine level of control. In this case, those symbolic lines will have been placed on the plan swing subcategory. If I untick that, you'll see that Revit displays everything except for that subcategory. This is a way of getting a much higher level of control over your objects. So just to illustrate that, if I open up this this family again, actually, no, that is correct. Okay, so if I just open that one up, what I'm going to do first of all is I'm going to create two pieces of geometry in here rather than just the single one that's in at the moment. I mentioned before about how Revit automatically takes care of placing the work plane. I'm going to make this new extrusion on top of this box. Revit actually makes that quite straightforward. What I can do is if I want to make the new work plane up the top there, I just go Set, Work Plane. Now remember before when I said that when replacing reference planes we can give them names? Well, this is a very good reason why it's good discipline to do that, because I can now pick that from the list, and you'll see that Revit has now placed that active work plane up on top. So if I go to Create and make another extrusion, Revit's now going to start creating that on top of the cube. And if I want to be really lazy here, I can just use the Pick Line tool and do that. You notice that as I use the Pick Line tool, Revit gives me that little padlock. That's saying, do you want to align, constrain that sketch line to the edge? And I most certainly do, because that way when the cube flexes, this object on top will flex appropriately as well. So there's my second piece of geometry. I'll just switch to another view. Okay, now if I wanted that just to be some sort of, say, 32 mils in height, I can just give that a dimension like so, and then I can, it's not going to let me do it automatically, but I'll just drop it down. Okay, that'll do. Okay, so if that wasn't parametric, there'd be nothing wrong with me dimensioning that and not even making it a label dimension, and then just padlocking it. So as the object flexes, then Revit will take care of just making this object 31 mils from the reference plane. And I don't have to worry about it any more than that. If I needed that to be a variable bench thickness, then I would need to make a new parameter called bench thickness and associate it with that label, that dimension, and make it a label dimension. One thing that's very important regardless is to always dimension to at least one reference plane. You always want to be doing that. Okay, if you don't do it, then things can go a little bit astray. If I dimensioned from extrusion to extrusion, even though that sort of doesn't seem terribly dangerous, there is a very good possibility that when I come along later inside the project, then the thing's going to start going a bit haywire. All right, so getting to the point that I started off with, if we go to the Manage Ribbon Object Styles, what I can do here now is create some new model subcategories. I'm going to call this Cube Body. Oops. And another one I'm going to call Cube Top, just for the sake of calling it something. And then all I need to do is click on the geometry, and now I can pick that. Oh, wrong one. Pick that from the list. Cube Top, Cube Body. Save it, load, make sure I overwrite. Okay, and that's great. So inside the project, there's my two pieces of geometry. And then in the visibility graphics for this view, if I go to Furniture, and we can see now that I've loaded that up, there's a new subcategory, two new subcategories that have been generated. I think I might have made a bit of a mistake there. Yeah, okay. Obviously, I blundered. Okay, let's go back and have a look, see what silliness I've done. Yeah, so I made that Cube Top. Very silly. Okay, so that'll fix that next time I load that up. But anyway, you can get an idea there of that's another degree of control that you've got in terms of, and it's not just hiding objects, obviously, it's also changing the line weight and the line style and so forth in your views. Okay, so that's one thing in terms of controlling the way that objects are shown or families are shown inside your project. Another very important thing is this whole concept inside views of your detail level. So when you're in a 1 to 500 view, obviously you don't want the same amount of information to show and as much detail in that view as you would in a 1 to 20. Okay, so in Revit that's handled by this detail level setting. Now we can actually take objects inside the families and get Revit to hide or show those at different detail levels. Now typically in Revit Families, when they're sort of being done to the standard Australian standards that they're made to, what you would typically do is take the geometry, and if we click on that little button here that says Visibility Graphics Overrides, typically what will happen is that they will be hidden in coarse and medium views and only visible in fine. Or sometimes, depending on the object, they might be visible in medium and fine. The reason being that the assumption is that your geometry is going to be that sort of fine level of detail. It's going to show quite a few objects on there. And as we start to go down and to coarse, that will then screen out the geometry and then perhaps show instead a symbolic simplified representation of the family rather than that fully detailed geometry. So we'll take those two extrusions and we'll tell Revit that in a fine detail level we don't want to see them. Now interestingly, it's very subtle, but inside the project environment Revit does try to show you a preview of the fact that that object is going to be visible or invisible at those detail levels. When I switch to fine, you'll notice that the edges around those extrusions are black, and if I change to coarse, you'll see that they're gray. It's just a little bit of a subtle thing that Revit does. It's very easy to miss. Okay, that's fine. Let's load that in and just, I guess, see what that's done. Click on course, and there go my cubes. Still there, but just not visible. That's sort of half of the actual process. The other process is to then put in that simplified symbolic representation that I mentioned just before, and that's done here in Revit by things like masking region. So a masking region, in a way, is a sort of it creates a mask that then blocks out any objects behind it. In the case of my family here, it's going to actually give the illusion that there's actually a solid object. So I'll just, again, using the pick line tool, which is a very effective way of doing this, and making sure I use the align constraint, I can create a masking region. So just importantly too, I just want to go into the visibility settings of that and make sure that that's not visible in Fine, so that when you're in a Fine view, you'll see the geometry and you'll see the materials. If I didn't switch that off in the Fine view, and I did go into my project, all you'll see is the masking region. And of course you won't see the geometry, so I'll make sure I switch that off. It's a bit like the reverse of the settings for the geometry, basically. The other thing that, as I mentioned, you typically see in Families is this symbolic line work. And just before I do create some, I'm just going to show you another little trick. If I go into the visibility settings for the view, I'm going to switch on automatic sketch dimensions. So what Revit can do is, if I'm going to create some symbolic lines, so I go to annotate symbolic lines, and what Revit will do is, if I use the pick line, and let's just say that the inside casework of this object, or carcassing I should say, is 32 mils. We can click here on the edge of the geometry, and you'll see that as I do that, Revit's creating those little dimensions. What Revit's actually doing is it's actually automatically creating relationships between that sketch line and the object that I used to pick to create that line, which is quite handy. Next thing I need to do is tell Revit what subcategory of line work this is going to be in. In this case, it's going to represent lines that are normally hidden inside. So in the case of standard working drawings, that would obviously be represented as a dashed line, of course. So Revit takes care of that for me. Okay, so I have created that symbolic line work. Again, you can go in and change the detail level and so forth. Load that into the project, overwrite, and you can see my symbolic line work. Just a very quick note: if you do create symbolic objects in a family, so if you did it, for example, in an elevation, just got to be very careful, because if I'm not in a section or elevation view that's exactly perpendicular to that plane that I'm in, then Revit will actually not show that object, if that makes sense. So you just have to be aware of that as a limitation. Okay, so we're getting pretty short on time here. I think we've got a few minutes left. So what I'm going to do, as promised, is just show you this idea of taking a family and readapting it. It's probably going to get a little bit more into advanced stuff. So I guess you know, if you hopefully get something out of this, or maybe not so much, you know, get something that you can actually reproduce immediately. At least get an idea of the possibilities that you can have inside Revit Families. So what am I going to do? First of all, I'm going to have a look at this in plan view. I've got some symbolic line work here, as I mentioned. Might just get rid of that one and just leave this arc here. What I'm going to do is I'm going to make this door swing parametric. So I want to make it so that I can actually represent the door swings in my project in different ways. So what do I need to do that? Well, remember before I mentioned reference planes? Reference planes are great, except that they only move, to put it technically, I guess, they move perpendicular to their own work plane. So in other words, if I've got this work plane here and I move it, it's only going to move backwards and forwards, okay? That is to say, it won't rotate. So Revit has this additional thing called a reference line. The reference line allows me to rotate it. So if I click on the reference line, if I create a reference line, I'll just go back a step. Okay, recreate that. I'll just do it like so, just so it's easier to see what I'm doing. Okay, so that's my reference line, and that's a bit different. It will actually allow me to rotate. Let's just make sure that's aligned correctly. So I'll use the align constraint. Okay, so that's going to rotate around, but what I need to do is tell Revit where the pivot point is. And to do that, what I do is, it's going to be a bit, I'll tell you what I'll do actually, just to make this a bit easier. I'm going to grab these objects like so, and I'm going to go down here to my little sunglasses, and I'm going to say isolate category. So now I can't see the symbolic lines and I can't see the geometry. That makes it a bit clearer. Bit of a trick there just to remember. I'm going to use the align constraint. I'm going to click on that reference line, and then there's another little trick. If I just tab through, you see the way I've got that green dot? That's basically the end of that reference line. So if I click on that and then click the padlock, I have actually locked the end of that sketch line or a reference line to that reference plane, and that will become the pivot point, hopefully. I'll just reset that. Okay, so the next thing I need to do is make this labeled parameter. In this case, though, because it's an angle, I need to use an angular dimension. And I'm going to pick that reference plane, and then I'm going to pick this reference line. I'm going to pick this reference plane to dimension 2. There's my 45 degrees, which is what it's set at. Also, I'm just going to change the view scale. That really doesn't affect anything, except it just makes things a bit clearer, makes the dimensions look smaller, doesn't do anything else. All right. Now, fortuitously, I actually already have a dimension in this family. What a coincidence. It's called door swing. And at this point, I would then flex this and make sure that it's working correctly. And it is. Okay, that's good. Now that may not always be the case. In the door family, this one just happened, and I didn't actually set this up. This just happened to have this parameter already set in here, and it was working correctly. In the case of a lot of door families that you open up, you might not find that that's the case. Okay, so we've got that. That's cool. I'll load that into the project. Okay, now you will notice there's a bit of a problem here. That's an instance parameter. You notice that it's allowing me to do that per door. Okay, but there's a few problems. And for example, if I make that 0, oh no, it didn't break on me. But sometimes Revit will sort of break if you go beyond a certain level or a certain dimension. In this case, it's working, but that's not often the case. So for example, let's just say that we wanted to constrain that so that it didn't go beyond 89 degrees and it didn't get less than 1 degree. That would be a pretty typical thing to do. This is a way of preventing your families from falling apart, basically. And so what we do is we actually create a formula, and this formula will be a conditional statement. So again, this is getting into more advanced stuff, but just to give you an idea of the possibilities, just to sort of, I guess, whet your appetite maybe. So first of all, we're going to make a new parameter, and we're going to call that, just to confuse things a little bit, I'm actually going to call that door swing, but I'll just make it a capital S, which is what it should have been in the first place. And we'll make it instance. Okay, so that's just sitting there doing nothing at the moment. But what I can do is copy that text, just Control-C and Control-V. Oh, didn't like that. Door swing, oh, why is that? Okay, let's just see what I've done wrong. Inconsistent units. All right, that's Revit is, of course, a computer program, so it's saying, I don't understand door swing. Why can't, well, I'll tell you why it's not working. Because, there it is. See, door swing I incorrectly picked as length. So in this case, it's actually simpler just to remove that parameter. Can't win that battle, so let's just admit defeat and instance, and because I wasn't concentrating, what I should have done is made an angle. And now that they're both the same type of parameter, that is to say that they're both angular, Revit will now allow me to do that. Okay, there's now a one-for-one mapping at this moment. Okay, it's just making a one-to-one relationship between the two. But what we need to do now is extend that. Okay, and the way that we do that, and I'm just going to switch over to Word here briefly. And when you're actually creating complex formulas in Revit, it is actually a very good idea to have something like Notepad open at the same time. Because if you have an error in a parameter, then Revit won't let you just leave it and go away. It actually forces you to fix the error at the time. So what you need to do is cut the text out, go back into your editor, make the change, paste it back in again. So what's that done? Well, let's see. It's made a conditional formula. And if all goes to plan, oops, so that's 90 degrees. You can see the door swing's 90. It's grayed out because it's being controlled by a formula. That's what I expect to see. Make it 45 degrees. There you go. So Revit's saying, yeah, that's cool. We're making it 45 degrees. Make it 2 degrees. Happy days. 2 degrees. 1 degree. Yeah, still going. 0. Whoops. No. Try again. 0. Aha. Revit's overriding it and making it 1 degree. And why is that? Because this formula is a test. It's an if statement. So what it's saying is, to try and, I guess, put it into some understandable format, and this is just the syntax that the Revit formulas use. You know, if door swing is more than 1 degree, then let this parameter here equal door swing, and then the comma says, if not, if it doesn't comply with that test, then make it 1. So it's like your fallback position. So if that parameter reads anything above 1, let it equal door swing. However, if it does not, then override it and make it 1. Okay. So let's just say, though, that we also need to control that so it doesn't go above 89 degrees. That's a little bit more advanced, as you can appreciate. This is what's called a nested statement, or a nested conditional format. There's 2 if statements in here, and if anybody studied logic or anything at high school or university, then this would probably make a bit of sense. It's essentially 2 statements. It's saying if door swing is less than 1, then make it 1. Otherwise, make it door swing. If door swing is more than 89, then make it 89. Otherwise, make it door swing. Slightly different way of arranging it, but effectively it's creating a nested statement, which is testing 2 simultaneous ranges. And again, if I set that to 0, Revit says 1. Set it to 45, yes. Set it to 89, all good. Set it to 95, 89, perfect. Okay, so that is, I guess, where we'll probably wind that up. So what I might do is, if anybody would like to ask any questions, say over the next 5 to 10 minutes, I'd be happy to answer any questions. Probably better if we can do it through the chat thing, the question through the actual text rather than through the audio, because I know that sometimes the audio can get a little bit scrambled if you've got multiple people sort of trying to talk at once. So if anybody would like to ask any questions, that'd be great. Or if you've all been awed into silence, that'd be great too. Okay, thank you. Oh, okay, let me just expand this dialogue so I can actually read that question. Just bear with me for 2 seconds. Ooh, what's it say? Okay, can you please explain why did you use a reference line for the door swing, not a reference plane? Yeah, so basically a reference plane can only move backwards or forwards on the plane that I created. So if I'll just switch back to the family environment just to give you an idea. So, you know, these planes here, these are reference planes. They will only move in and out like so, okay? The reference line can be rotated. That's purely the only difference. So you use a reference line when you have to rotate the object, only when you have to rotate the object, and you use a reference plane when the object is moving backwards and forwards along a preset plane. Does that sort of answer that? I'm just having some problems here with my GoToMeeting thing, trying to get it to expand out so I can actually see all of the questions. Let's see if there's anything else that's popped up. So yeah, okay, good. Okay. So I don't think there's any other questions there. All right. So, okay. Well, I think that's. I don't think there's any other questions popping up. So I think that's probably an indication that that hopefully I've explained the concepts in some reasonable clarity. It is a pretty complicated part of Revit. It's really the next step. Once you've gotten your head around the Revit project environment, you really need to start getting into the Revit families. I guess it's just one of those things where you know it's good to sort of bite the bullet and try and get your head around it. But having done something like this, I would expect that you're going to find this whole process an awful lot easier than it would be if you were trying to sort of nut it through by yourselves. So hopefully I've given you a really good sort of 101 understanding, and when you go to open up a Revit family from now on, you've got a much better understanding of how it all was put together and how you can manipulate it. All right, ladies and gentlemen, I'll leave you now, and thank you all for attending, and I hope you got a lot out of it. Thank you.